Good morning, geometry class. It's Wednesday, and I hope you guys have a great day. Lord, watch out with these guys and just keep them safe. And Father, I pray that they would understand what the math is today and that it'd be easy for them. In Jesus' name, amen. Okay, so today we're going to keep going with what we had yesterday, pyramids and cones. I noticed only a couple of you done your assignment yesterday, so maybe today's video will help you as well as yesterday's. Make sure you get that done though by 3 o'clock. If you have questions, 12:30 to 3:30, you can ask me any school day. Just give me a call. All right, so the first thing I want to look at is just a cone. I think the pyramids are pretty simple, but a cone, if I come over here and steal George's hat right here, you can see that I've got a cone. And if I take George's hat and I rip it apart, you'll notice that if I fold it open, it looks just like kind of like a fan a little bit. But there's your funny looking triangle. In fact, if I come over here and put it right here, kind of fits in here a little bit. You'll notice at the bottom of that was the circle of George's hat. And so that's why it's pi times d, because circumference is pi times d. And then there's our slant height here, which is really close to the true height anyway. So when you do the area for this, you're going to do pi times d times the slant height, and then divide by 2. You divide by 2 because it's a triangle. Okay, so now let's look over here at what we did. This is actually number 11 in yesterday's homework. They had a cone and a cylinder and a cone. And all you have to do is basically the surface part of the top one is just the triangle. The middle one's the rectangle. And the bottom one is the triangle again. It's upside down, but that doesn't really matter. Okay, and so the two circles in here you really don't care about because they're on the inside. They're not on the surface. And so we get to skip the circles part. Don't need them. So we're going to go ahead and plug this. So and I always do the formulas first. I think it makes it easier for me to know exactly what I'm doing and keep track. So the formula for this first one's pi dh divided by 2. This one's just pi d times h because this part right here wraps around the circle, so that's pi times d. And then that's h, the height of the cylinder, which would be 15. And then plus pi dh divided by 2 again for the bottom one right here. So when I put numbers in here, what I did was I put pi times 24 because the radius was 12, so that would mean the diameter would be 24. And the slant height of the top one was 26 divided by 2 plus pi times 24 is still going to be the diameter of the cylinder because it's a diameter of the cone. And then times 15 because it's the height. And then this one right here is going to be pi times 24 again because that's the diameter. 32, that's the slant height. And then all divided by 2. And then if you do the math for that, you take this times this divided by 2, you get 312 pi plus 360 pi plus 384 pi. And the reason I left pi is because when I looked in the book, they just left pi in the answer. And actually, it's much easier to do it that way. So all you have to do is add 312, 360, and 384 together, and you get 1,056 pi meters squared. Now, if you got it the other way and you want to know if you got it right or not, you do 1056 times 3.14, which would give you 3,315.84 meters squared. In the directions, they didn't tell which one they wanted, so I would take either one. That's absolutely fine. So I hope that makes it simple and clear what I did. Rewind and look at it again if you need to. Okay, your work for today is 13, 16, 17, and 21 on page 694. So I'm giving you 4 problems. Please show your work and your answer. Okay, of course, the right answer would be good. And make sure that you put your units on meters squared or centimeters squared or inches squared, whatever it is. All right, again, call if you have questions. Have a great day.